so far we've seen how we can use process to test for interactions between predictors, regardless of whether the predictors are both continuous or whether we have one of each, one continuous and one categorical. But in all of the examples we've looked at so far, our outcome, the thing we're trying to predict, has been continuous, whether it's narcissism score or what have you. What we're going to look at in this lecture is how we can also use process to test models where our outcome is categorical. So here's our big chart of all the tests that we've learned again and all the situations that we might have to deal with. We've now covered this entire box over here. So we can use process and use regression to test for interactions between two continuous predictors or an interaction between a categorical predictor and a continuous predictor when our outcome is continuous. But the good news is we can also use process regardless of what our predictors look like. We can also use process when our outcome is categorical, which we'll see today. So here's the first example that we are going to walk through. There was a very famous political debate in 1960 between Richard Nixon over here and John F. Kennedy over here. And the reason this debate was such a big deal, it was the first ever time that a presidential debate was televised. And it really showed how people judge candidates based not only on what they have to say, but also on their appearance. Because some people listen to the debate on the radio, other people listen to the debate on television. And even though they were listening to the same debate, the people who watched on TV came away with very different impressions of the candidates than the people who listened on radio did, likely because they could see that JFK was a pretty handsome guy. And since then, there's been some research on how attractive political candidates tend to be perceived more favorably than those that are not. And generally speaking, people tend to be biased in favor of voting for the political candidate that's more physically attractive. The question is, why do we think this happens? And there's a couple different explanations for this, right? You might talk about the halo effect, for example, in social psychology, where we assume that a person who possesses one good characteristic also tends to possess other desirable characteristics. So if a person is attractive, we also tend to think that they're smart and well-spoken and kind and all these other things that are also good traits for a person to have. But another explanation for this that's been proposed is that being physically attractive is also a sign of being healthy. And people generally, for evolutionary reasons, might prefer to have leaders that are healthy, leaders that are not going to die in office, for example, and leave his or her constituents without a leader. So that's what this study set out to test, is they predicted that people generally prefer physically attractive leaders, but this effect would depend on how much disease threat is present. In other words, in areas where there's reason to be concerned about a candidate's health, this relationship might be stronger or weaker than in areas where people tend to be healthier. So here is how they went about looking at this. They actually used the actual data and candidates from the 2010 U.S. congressional elections. And here's the model that they set out to test. So first, what they actually did is for each of these candidates, they had people who knew nothing about the study just rate how physically attractive they thought each candidate was. So for each political candidate, they had a mean rating of that candidate's physical attractiveness, which they used as their X variable. And they wanted to see whether the candidate's physical attractiveness predicted the likelihood that they would win the election, which is, of course, a binary outcome, right? They either won the election or they didn't. So if we were just testing this XY relationship, we would just use a simple logistic regression, where X is our predictor, physical attractiveness, is predicting whether they won the election or not. And we talked about logistic regression a few weeks ago, and what we're doing today is not going to be all that different from that. The difference is now we're going to add a moderating variable. And in this case, our moderator is going to be disease threat, which they operationalized as the life expectancy, the average life expectancy in the congressional district where that candidate was running for office. So their hypothesis was that physical attractiveness would predict the likelihood of winning the election, but that relationship would depend on the life expectancy in that particular congressional district. So here's our data file called hotcandidate.sav. For each political candidate, we know three things. We know how attractive they are, as judged by other people who knew nothing about the study. We know the average life expectancy in their congressional district, and we know whether they ultimately won the election or not. So there's just those three variables again. Now, this is unlike the examples that we've done in the past couple weeks, the key difference being that now our outcome is binary. But the good news is that we can test this model in Process anyway. Process will automatically detect the fact that our outcome is binary, and it will know that it needs to use logistic regression instead of ordinary regression to test this model. Now we can also fill in this big block over here using Process. Regardless of whether our predictors are both categorical, both continuous, or one of each, it doesn't matter. We can still use Process to test for an interaction between them when our outcome is dichotomous. All right, back to our data file, hotcandidate.sav. We're going to open up Process, and here's what we're going to do. Our X variable is going to be the attractiveness of the candidate. Our moderator is the life expectancy in their district, and our Y variable is the binary, did they win the election or didn't they? In the options menu, we're going to do the things that we usually do. So we're going to generate code for visualizing the interactions. We're going to ask Process to mean center our continuous variables, and we're going to set the simple slopes analysis at plus or minus 1 standard deviation. So all the stuff that we normally do. And again, remember, we don't have to do anything special with the Y variable because Process will automatically detect that it's a binary variable. Okay, so we run the test. Up pops our output. This is our coefficients table. We have a row for alpha. We have a row for life expectancy. We have a row for attractiveness. And we have a row for the interaction. So what we see here is that life expectancy was not a predictor of whether a person won the election or not. Attractiveness actually was marginal, but not a significant predictor of who won the election. But as we'll see in a second, the interaction was in fact significant. When we ran logistic regressions in SPSS a few weeks ago, we got a test called the walled chi-square test, and that's what we reported for logistic regression results. Process doesn't give us that. So instead, what we're going to report is just the beta. This is the coefficient right here, is the beta for each of these. And of course, we'll also report the p-values indicating whether the predictor was or wasn't significant. So as I just mentioned, neither of the main effects was significant. Neither attractiveness nor life expectancy was a significant predictor of whether a candidate won or lost, but the interaction term was significant. So to make sense of that, we have to go and look at our simple slopes analysis that's going to break our results down as a function of life expectancy. Here are the results of that simple slopes analysis. So this first row tells us about districts where the life expectancy is low. The second row tells us about districts where the life expectancy is average. And the third row tells us about districts where the life expectancy is above average or high. So in places where the life expectancy is low, attractiveness was a significant predictor of the outcome of the election. So in places where the life expectancy is low, the more attractive candidates were more likely to be elected. In places where the life expectancy was average, there was a marginal relationship. So not a significant one, but you could argue some tendency for attractiveness to predict winning the election. But in places where life expectancy was high, no relationship whatsoever. So there is a relationship between attractiveness and winning a political election, but only in places where the life expectancy was low. If we want to graph our results, we can scroll down to the bottom of the output, copy and paste that syntax. We'll get a graph that looks like this, which I'll add the lines to again. The blue line shows us the relationship between attractiveness and the probability of winning the election in places where the life expectancy is low. So in places where the life expectancy is low, there is a clear positive relationship between attractiveness and the probability of winning the election. More attractive candidates are more likely to be elected. In places where life expectancy is average, looking at the green line, this is where we saw a marginal relationship, which kind of makes sense given what this line looks like, right? There was some tendency for attractive candidates to be more likely to win in those districts. But in places where the life expectancy was high, the brown line, the line is fairly flat, right? So no relationship in those districts between attractiveness and the likelihood of winning the election. Attractiveness, life expectancy, and their interaction, and we found that the interaction was indeed significant. So then we did a simple slopes analysis to make sense of it, and what we found is that more attractive candidates were more likely to be elected in places that had a low life expectancy, but not in places where the life expectancy was average or high. In other words, there is a relationship between attractiveness and winning election, but only in places where the life expectancy is low. And in fact, that's exactly what they found. They did it in two different ways, interestingly enough. So first, they did it where the outcome was continuous. Rather than trying to predict whether the person won the election or not, which is binary, they tried to predict the percentage of votes that a candidate received, and they did find a significant interaction there. Then they did what we just did. They predicted the binary outcome. Did they win or not? And in both cases, there was a significant interaction. So if we broadly think about the outcome variable as being election success, we get the same pattern of results regardless of whether we define success as winning versus losing, or if we define success as how many votes you actually win. All right, so, I mean, in a sense, we haven't really learned anything new today. We've just learned one more thing that process can do. And we've built on our earlier lecture on logistic regression to see how we can also include interaction terms in a logistic regression using process. So here's another example for you to practice on. This is a situation where, again, I'll introduce the problem, and if you want to pause the lecture and do this on your own, I'd strongly encourage you to do that for practice. The premise of this study is that stress increases vulnerability to disease, right? That's fairly uncontroversial. The way that they operationalized stress in this study was the number of days in the past 2 weeks that a person has experienced interpersonal tension. And then after that, and I have no idea how they got IRB approval for this, but they actually exposed people to germs and measured whether they got sick or not. So the predictor variable is how much stress, how much interpersonal tension they had experienced in the past 2 weeks. And then the outcome variable was whether or not they got sick when they were exposed to these particular germs. Now, these authors of this study predicted that social support would actually moderate this relationship. That, in other words, the effects of stress on health wouldn't be as strong for people who have high levels of social support. And the way that they operationalize social support is pretty adorable. It's the number of times in the past 2 weeks they've gotten a hug from someone else. So that's going to be our moderator variable. Their prediction is that there will be a relationship between stress and getting sick, but that relationship will be weaker for people who have been hugged more frequently. So here's our data file. For each person, we know their stress score, which again is operationalized as the number of days in the past 2 weeks where they experienced interpersonal tension. We know whether they got sick or not when they were exposed to the germ. So this is going to be our binary outcome variable in this logistic regression. And we have our moderator, which is the number of times in the past 2 weeks that they've gotten a hug from someone. So I want you to build a model using process to test the following things. First, you're going to look for just, was there a main effect of stress? So if we ignore our moderator, was increased levels of stress associated with an increased likelihood of getting sick? Then tell me if the interaction was significant. Did the nature of that relationship depend on the number of days that a person had gotten a hug? And if so, you're going to perform a simple slopes analysis, and you're going to tell me how this relationship looks different for people who got a lot of hugs versus for people who got very few hugs. And use process to make a graph of this relationship so you can actually show the simple slopes. So if you want to pause and try this for practice, now is the time to pause. All right, let's work through this. So here's how we would set it up. Our x variable, our predictor, is the number of days in which they have experienced interpersonal tension. That's how they measured stress. Our outcome variable is binary. It's whether they got sick. They either did or they didn't. And our moderator variable is the number of days that they received a hug in the past 2 weeks. Now again, in the options menu, as we always do, we're going to do 3 things. We're going to ask for the syntax to get a graph. We're going to ask process to mean center our continuous variables. And we're going to set the simple slopes analysis at plus or minus 1 standard deviation. Okay, so we could report the interaction here, the z-test. We could also report the interaction as a chi-square test down here. Here's a chi-square statistic and a p-value for the interaction term. Jeez. Okay, so there is a positive relationship between stress and illness. Stress does increase the likelihood of getting sick, but in this case, it was only for people who got a low or average amount of hugs. In other words, in this particular study, getting hugged frequently actually protected people's immune systems against the damaging effects of stress. Here are our results. So I talked about the main effect first, since I asked you to talk about that one. A logistic regression found that increased tension or stress predicted higher risk of illness, but that effect was qualified by a significant interaction between tension and hugs. When we do our simple slopes analysis, and our graph looks like this, people who got a lot of hugs did not show a significant relationship between stress and illness. But people who got few hugs, or even an average number, did show a significant positive relationship between stress and illness. So more days of stress predicted a higher likelihood of getting sick, but only for people who were relatively low in social support. Here are the results of that study. So here you can see they tested the tension by hugs interaction. They call it the cross product term. And they found that the effect of tension was dependent on hug frequency. So all 3 of these variables were related to each other. Here's how they reported their interaction. And here's how they showed it in a graph. So these were people who had a unusually low number of hugs. And you can see there's a positive relationship there between tension and predicted probability of getting sick. For people who had a relatively high number of hugs, no such relationship, as indicated by the solid line. And there you go. So again, in this particular lecture, I wouldn't say we've learned a whole lot that was terribly new, But we have extended something that we learned previously, namely logistic regression, and seen how we can use process to make it very easy to test interactions in a logistic regression context where our outcome is binary. So we now know we can use process with continuous predictors, categorical predictors, continuous outcomes, and categorical outcomes. Basically, anytime we're testing for an interaction, we can use process to test for it, no matter what kinds of variables we're dealing with.